So for next example, refer to the example 4.11, page 144. So I will discuss example C only. For example A and example B, you have to do as your own exercise. Okay, now for this example, we have 4s square divided with s square minus 36 multiply with the s minus 6. For the s square minus 36, this one is the quadratic term. So for this quadratic term, you have to check whether you can factorize or not. So by using calculator, s square minus 36 can be factorized. So s square minus 36 can be factorized, whereby s square minus 36 will become s minus 6 s plus 6. So now the terms that you have factorized, you have to substitute back to the position whereby you have the quadratic term. Okay, so for the s minus 6, this one is a linear term. Substitute back into original question. 4s square divide with s minus 6, s plus 6 and s minus 6 at the behind. So s minus 6 here is from the original s minus 6. As we can see here, there are two terms for the s minus 6. Okay, so therefore this one will become a repeated linear term. So this one can be written as 4s square divide the whole thing s plus 6 s minus 6 with the power of 2. So this one will become a repeated linear term. So this one is the linear term. So now write this one in terms of the partial fraction. 4s square divide with s plus 6 s minus 6 the power of 2 is equal to a over s plus 6 plus b over s minus 6 with the power of 1 plus c over s minus 6 with the power of 2. So now in order to find the value of constant a, b and c, you have to create an equation by eliminate the denominator at the bottom side here. For the left hand side, we always copy down whatever you have at the upper side. 4s square is equal to a is divided with the s plus 6. So we cancel out s plus 6 here, means that s minus 6 the power of 2 will be multiplied with a. So a will be multiplied with the s minus 6 the power of 2 plus b is divided with the s minus 6 power of 1. So we will cancel out s minus 6 with the power of 1 on the left hand side. So we cancel out 1, means that these two things will be multiplied with the b. S plus 6, s minus 6 plus c multiply. C is over s minus 6 power of 2. So for the left hand side, we will cancel out s minus 6 the power of 2. So s plus 6 will be multiplied with the c. So from here, you have to find what is the value for the constant a, b and c. So for this question, I will use method 1. Find value a, b and c by substitute any suitable value of s, so that the bracket here will become 0. So in order to choose the suitable value of s, you have to refer to the partial fraction that you have right before this. refer to the left hand side, whereby you have term at the denominator here, s plus 6 and s minus 6. For the first bracket here, what is the suitable value of s? When you substitute to the s plus 6, it will become 0. So the suitable value of s is equal to negative 6. For the second bracket here, the suitable value of s is s equal to 6. So means that there is only two value of s that is suitable to be substituted. So let s is equal to negative 6. So you have to substitute s equal to the negative 6 for the equation that you have created before this. 4s square means that 4 multiply negative 6 the power of 2 is equal to a multiply s minus 6, negative 6 minus 6 the power of 2. Negative 6 minus 6 the power of 2 plus b multiply s plus 6, negative 6 plus 6 multiply s minus 6, negative 6 minus 6 plus c multiply s plus 6. So negative 6 plus 6. Negative 6 plus 6. So now you have to simplify the whole thing. Simplify from the left hand side. 4 multiply negative 6 square. So this one will become 144 is equal to a multiply negative 6 minus 6 the power of 2. So this one will become 144 plus b multiply negative 6 plus 6, this one will become 0. So b multiply with any number, the whole thing will become 0. Plus c multiply negative 6 plus 6, this one will become 0. So therefore a is equal to 1. So now substitute s equal to positive 6. So copy down back our equation here. We want to substitute s equal to positive 6. So let s is equal to positive 6. So you have to substitute all s here to become positive 6. 4 multiply 6 the power of 2 is equal to a multiply 6 minus 6 the power of 2 plus b multiply 6 plus 6, 6 minus 6 plus c multiply 6 plus 6. So now simplify the whole thing. From the left hand side, 4 multiply 6 the power of 2. This one will become 144 is equal to a multiply 6 minus 6 the power of 2. This one will become 0. So a multiply with 0 plus b multiply with 6 plus 6, this one will become 12. 6 minus 6, this one will become 0. So b multiply with anything that contains 0 will become 0. Plus c multiply 6 plus 6 will become 12. So 144 is equal to 12c. So therefore c is equal to 12. So now there is no more suitable value of s that is suitable to be substituted. So we can choose any value of s. Let's say we choose s is equal to 0. So substitute s equal to 0 for every terms that you have s here. 4 multiply with 0 the power of 2 is equal to a multiply with 0 minus 6 the power of 2, 0 minus 6 the power of 2 plus b multiply 0 plus 6 multiply 0 minus 6, 0 plus 6, 0 minus 6 plus c multiply with the 0 plus 6. Okay, now simplify the whole thing. For the left hand side, 4 multiply with the 0 will become 0. A multiply with the 0 minus 6 the power of 2. This one will become 36 plus b multiply 0 plus 6 will become 6. 0 minus 6 will become negative 6. So multiply these two things will become negative 36. Plus c multiply with 6. So we already obtained the value of a and c. So now you can substitute a is equal to 1 and c is equal to 12. 0 is equal to 36 multiplied with 1 plus b multiply negative 36 plus 6 multiplied with 12. So simplify the whole number. Negative 108 is equal to negative 36b. So therefore b is equal to 3. So now you have to substitute back value a, b and c into the partial fraction. So now based on our calculation, a is equal to 1, b is equal to 3 and c is equal to 12. So you have to substitute all the value here in the partial fraction that you have right before this. So 4s squared, divide the whole thing with s plus 6. S minus 6 the power of 2 is equal to a will become 1. 1 over s plus 6 plus b will become 3. 3 over s minus 6 plus c will become 12. 12 over s minus 6 the power of 2. So now we have to solve for the inverse Laplace transform. So write the notation for the Laplace inverse curly bracket for the whole thing. Okay, so if you have any constant at the upper side, you have to bring the constant to the front. So for the first curly bracket, there is only constant 1 at the upper side. For the second curly bracket, we have constant 3. So bring 3 to the front. So for the third curly bracket, we have 12. So bring 12 to the front. Laplace inverse 1 over s plus 6 plus 3 Laplace inverse 1 over s minus 6 plus 12 Laplace inverse 1 over s minus 6 the power of 2. So by refer to the table, this one is the suitable whereby we have a constant at the upper side 1 and s with the power of 1 at the bottom side. So the answer will become exponent of 80. So Laplace inverse 1 over s plus 6, you have to determine the value of a here. So our a is equal to negative 6. So for the second curly bracket, the same thing, the answer will become exponent 80. So our a here is equal 6. A is equal to 6. But for the last curly bracket here, we cannot directly change this one become exponent 80 because we have s minus 6 with the power at the outside. So for this one, we have to apply first shift inverse Laplace transform. Okay, so let us simplify for the first two curly bracket. Laplace inverse 1 over s plus 6. A is equal to negative 6. Therefore, the answer will become exponent negative 6 t plus 3 Laplace inverse 1 over s minus 6, whereby our a is equal to 6. Therefore, the answer will become exponent 6 t. 3 exponent 6 t plus 12. Laplace inverse 1 minus 6 the power of 2, we have to apply first shift inverse Laplace transform. So in order to apply first shift inverse Laplace transform, we have to determine the value of a. So for this one, a is equal to 6. So once we declare the value of a equal to 6, we have to write exponent at at the front of the Laplace inverse. So 12 exponent 6t Laplace inverse 1 over, we will change s minus a, whereby s minus 6 the power of 2 will become s the power of 2. So from here, we will refer to the table of the Laplace transform. So by refer to the table of the Laplace transform, whereby we have s with the power at the bottom side, the suitable one is n factorial over sn plus 1, whereby the answer will become t the power of n. So from here, we have to determine the value of n. N plus 1 is equal to 2, so therefore n is equal to 1. So write back our answer. Exponent negative 6t plus 3 exponent 6t plus 12 exponent 6t Laplace inverse. Write back Laplace inverse 1 over s square in the terms of n factorial over sn plus 1. So n is equal to 1. So this one will become 1 factorial over s the power of 2. So when we write 1 factorial at the upper side here, you have to divide with 1 factorial at the front here. So divide with 1 factorial. For this one, there is no effect because it's only the value of 1. Exponent negative 6t plus 3 exponent 6t plus simplify 12 over 1 factorial will become 12 exponent 6t. Laplace inverse 1 factorial over s the power of 2 will become t the power of n, whereby our n is equal to 1. So therefore multiply with t the power of 1. So this is the final answer for this example.